Okay, so this is the second part of R4. And we're going to talk about these special polynomials factoring. We're really going to look at a lot at the sum difference of two squares and the sum or difference of cubes. The perfect square trinomial, we're going to factor just like normal. And then we'll see at the end that it ends up being a binomial square. So just like with numbers, if a number doesn't have any factors, we call it prime. So if a polynomial is not factorable, we call it prime. Okay, so prime, if it doesn't factor, prime is the word we use. Most of these will factor. This section is over factoring. So don't think like just because it's hard to factor, it's going to be prime. Most of the time it factors. Every once in a while, it will be prime. Okay. Prime. Prime. Yep. So if it doesn't factor, you can write prime. Okay, factoring special forms. So we got to check for common factors. So every time you go to factor something, look for a common factor first. Not a common factor to take out. It's a binomial. So binomials will only factor more if they're one of the special binomials. So is x squared and 25, are those perfect squares? Yeah. Is it subtraction? Yes. So this is difference of squares. Okay. So I'm going to just write that here. You don't have to tell me what it is before you factor it, but I just want for notes for you to know, okay, this is the difference of squares. Difference of squares factors to two binomials. And then what's the square root of x squared? What's the square root of 25? 5. And then 1 is plus, 1 is minus. Remember, those are the conjugates. It doesn't matter if you put the minus and then the plus, like if you switch the order of the addition and subtraction. But 1 is plus, 1 is minus. Okay, here. Is 16x squared a perfect square? Yeah, what about 1/9? Yes, because 1 is a perfect square and 9 is a perfect square. So 1/9, that's how you think about square roots of fractions, square root at the top, square root at the bottom. So what is the square root of 1/9? 1/3. Okay. So this is also a subtraction, difference of squares. So 16x squared, what's the square root of that? 4x. The square root of 1/9. 1/3. 1 is addition, 1 is subtraction. Okay, let's look at this third one here. So first of all, I want to take out a common factor if possible. Well, I see that 9 could go to 36 and 81, so maybe check to see if it goes into 108. If it does, then let's take out a 9. Remember, the quick way to check to see if 9 goes into something is to add the digits. And if 9 goes into that, then it will go into this whole number. So 8 plus 0 plus 1 is 9. 9 goes into 9, so it can go into 108. Okay, so let's factor out a 9. I want to do whatever I can to make these numbers smaller so it's easier to factor. So I get 4y squared. What times 9 gives you negative 108? Negative 12y plus 9. Okay, so then I just have to factor this. So it's a trinomial. I'm going to try to factor it to 2 parentheses. So what should I try for my first 2 spots? 2 and 2. Let's try 2y and 2y. Okay, what should I try for the last 2 spots? Let's try 3's, and then what about their signs? Both negative, because it's a positive 9, and then that's a negative 12. Okay, let's see. My outer is negative 6y. The inner is negative 6y. Negative 6y, negative 6y, does that give you negative 12y? Yes. So this is done. But since 2y minus 3, 2y minus 3 are the exact same, I can write it like this. Now, I don't care which way you do. You don't have to do it like this last way, but I want you to recognize it. So if it were a multiple choice question and you got to here, but the answer was given like this, you would know those are the same. Okay? Okay. Alright, so when you have multiple variables, it's really going to factor the same way because since this is a v squared here, and then you had a u squared here, it still follows that quadratic pattern, and you can factor it to 2 binomials. Okay, so 9u squared, what should I try for my first 2 numbers, the first 2 in each parentheses? 3u and 3u. Alright, if that v weren't there, what should I try for 16? Let's try 4 and 4. Well, I need v squared, so I'm going to try 4v and 4v. What about my signs for that one? Yeah, both positive. Let's check. All right, my outer, what's 3u times 4v? How would I write that? 12uv. What about 4v times 3u? 12. Let's say I write it like this. Are these like terms? Yes. It doesn't matter the order of your variables. So if you wanted to look the same, just always write them in alphabetical order. So even though you're doing v times u, that's the same thing as u times v. And then you see that, okay, yes, that is 24uv. Since those are identical, it's tough to go from here straight to here. That's why, like I said at the beginning, the 2 patterns that we wanted to look for were difference of squares and some are difference of cubes. But binomial squared, it's tough to go from the beginning right to here. Oh, v, 4v. Yeah, thank you. 4v. But it's still tough to go from this to this. The only thing that I could say would maybe give you a hint is if the first and the last are perfect squares, then you could try it first, try that, and see if it works. Okay. All right, let's look at a few more. So the x squared plus 4, no common factor. So I'm checking difference of squares. Are these perfect squares? Yes. Am I subtracting? No. There is not a way right now, we'll learn eventually, a way to factor our sum of squares. Sum of squares is not a special rule. So, I will say that's prime. Okay, let's look at the next one. Well, I know this will be x and x. I'm going to write these out. So let's try 2 and 3. And what has to be true about my signs? They have to be both negative or both positive. So I'm taking negative because of the minus x. My outer is negative 3x, and the inner is negative 2x. Does that give me negative x? No. What if I did this? Would that give me a negative x? No. Okay. So it's not 2 and 3. Let's try both negatives again. Negative 1x and negative 6x. Does that give me negative x? No. What about plus 6 plus 4? No. This one is also prime. You have to try every possibility before you could say it's prime. You can't do one positive, one negative because you have to multiply to be a positive 6. Questions about that? Okay, let's practice sum and difference of cubes. You do have to have this memorized, how to factor these, like the, so you want to look at that rule that you wrote at the very beginning. Okay, so I check for, I see it's a sum, so I check for perfect cubes. Y cubed is a perfect cube. 64 is a perfect cube. So let's talk about A and B then, so I can look at this rule here. So A cubed plus B cubed. I'm going to do A and B. So A and B are the cube roots of the perfect cubes that you have. So A would be Y, and B, what's the cube root of 64? 4. Okay. Square root is 8. That's okay. It's okay. Okay. So the first thing it tells me to do is A plus B. So Y plus 4. And then it says A squared. So what's A squared? Y squared. And then it says minus AB. So what's Y times 4? 4Y. And then it says plus B squared. So 4 squared is 16. Okay, the pattern already does these signs for you. So don't worry about any signs. Just you could go ahead and put a plus and then minus plus here before doing any of the numbers. It already has the signs worked out for you. It also breaks it down to it factors all the way. This trinomial will not factor anymore. It's set up that way. Okay, so this will not factor any further. I went right. That this was the sum of cubes. Okay, this one will be the difference of cubes. Okay, what is the cube root of 8t cubed? 2t. So A is 2t. What is the cube root of 1? 1. Don't worry about the sign. Don't worry about the sign. Just look at 8t cubed and a 1. Don't look at the subtraction because it already has those worked out for you. Okay, so difference of cubes is now a minus b. So 2t minus 1. And then a squared. So what is 2t squared? 4t squared. Don't forget when you square 2t, you square the 2 and the t. Plus 2t times 1. 2t. Plus 1 squared. 1. Okay, so what I like to think about when I'm doing these is that my binomial will match what I have. So if it's difference, then I'm gonna have difference here. Okay, and then it's the opposite of what's inside. Opposite of that for the trinomial. Questions about those? Okay. Do some more factoring. Okay. So, no common factor. Let's check. It's subtraction. So it could be difference of squares. It could be difference of cubes. Is n to the 6th a perfect square? It is, actually. Is 64 a perfect square? Yes. So difference of squares works. Is n to the 6th a perfect cube? Yes, it is. Is 64 a perfect cube? Yeah. So it's actually both. You could do difference of squares and difference of cubes. And we'll want to start with difference of squares first. Okay, so I know it's a perfect square because this can be divided by 2. Remember, square root, the fraction, the exponent for that would be 1/2. And you could do 1/2 of 6. Cube root, the exponent would be 1/3. And you could do 1/3 of 6. So I know it's a perfect square because 2 goes into it. I know it's a perfect cube because 3 goes into it. So we'll start with difference of squares. So the square root of n to the 6th. So what's 1/2 of 6? 3. So it will be m cubed. And the square root of 64, 8. And 1 is plus, 1 is minus. So now I have the sum of cubes and the difference of cubes. N cubed is a perfect cube, 8 is a perfect cube. So what is my A? What's the cube root of n cubed? What is my B? What's the cube root of 8? 2. Okay, so do the sum of cubes for this. Write that out. use your rule there. Get some practice. You could. It's not going to end up looking the exact same. This will just factor down further than the other way. I wouldn't count you wrong if you started with that. just make sure one of those would be difference of squares. After you did difference of cubes, make sure to factor that all the way. Yeah. Okay, so when I factor this, I'll have m plus 2, and then I have m squared minus 2m plus 4. Okay? That's how that sum of cubes should have factored. This one is the difference of cubes. My a and b are the same, so a is m, b is 2. Again, don't worry about the sign. The sign will come out here when you factor. Okay, so you do a minus b, so m minus 2. And then a squared, m squared, plus a times b, so 2m, plus b squared, which is 4. Okay, I don't care about the order, so once you have this, you can be done. You don't need to rearrange anything. We're not trying to multiply anything back together. Okay, so we're factoring. Yes. Sure. Okay, any questions about that? Okay, so I kind of asked if we could do difference of square or difference of cubes first, and you can. You can. It'll just look a little bit different here. It won't be quite as factored, but I wouldn't take off if you did that. Okay? All right, so let's keep practicing. We're just going to keep practicing. How am I supposed to factor when I have 4 terms? Yeah, grouping. So we want to group these. Group the first 2, group the second 2 terms. What do I want to factor out here? X squared. What will that leave me with inside? 2x minus 1. What do I want to factor out of my second group? Negative 3, because I need the signs to switch. I want positive, negative, and this one is negative, positive. So negative 3, which will give me my 2x minus 1. Now what's the common factor? 2x minus 1. And I'm left with minus 3. Let's say, I'll change this back, but let's say you factored that and it ended up being like this. I could factor that further, so I would have to have one more step and finish like this. Does that make sense? Okay. Now, since it's a not difference of squares, since 3 is not a perfect square, sometimes your book will still factor it like it is difference of squares. 3 is not a perfect square, so the only thing you could write that as would be like this, with the radicals there. So you might see this as your answer. I'm fine with you leaving it like this, unless that's a perfect square. But it is possible to write it like this second right here. Okay, look at the next one. This is a trinomial. It's quadratic. Is there a common factor to take out? No. So we'll just check our two parentheses. Guess and check, which is FOIL backwards. All right, so what do I want to put for my first two numbers? 3x and x. 3 and 1 are the only thing that multiply to give me 3. Now I need factors of 8. Well, what could I try? I can try 4 and 2 or 2 and 4. I need a positive 8, so what do I need for my signs? Okay, 2 positives or 2 negatives, but since that's a positive, I'm going to try positives. What's the outer? 6x. What's the inner? 4x. Do those give me 10x? Yes. Okay, let's look at this one. So this is another trinomial. Check for a common factor. Is there a common factor to take out? No. So it's not quadratic, but it follows a quadratic pattern. And it'll follow a quadratic pattern if you decrease by the same amount of your exponent every time. So when it was this, your exponent goes 2, 1, 0. Okay, here, 4, 2, 0. So you decrease by 2 every time. If it were this, that's a quadratic pattern, 6, 3, 0. Okay, can you see the pattern? 8, 4, 0, that would work too. Okay, so if it follows a quadratic pattern, it still factors the same way. So it still factors to two binomials. But instead of x and x, it'll be x squared and x squared. That's what multiplies to give me x to the fourth. Okay, so what factors of 12 am I thinking I want to use? Yeah, 2 and 6, because I see a 4. It's a negative 12, so I need one positive, one negative. I want to add to be a negative 4, so which one do I think needs to be negative? 6 and positive 2. Are either one of these difference of squares? No. You have to check. You have to check for that if you see an x squared or a variable that's squared if you have a difference of squares. Okay, questions about that? Okay. We have just a few more practice ones we want to do. All right, do this first one. There's not a common factor, but I see perfect squares and subtraction. So difference of squares. What's the square root of 25? What's the square root of 16n squared? 4n. 1 is plus, 1 is minus. If you wanted to write it the other way where your variable is first, make sure you include your negative here. So this is correct, and I'm fine with you leaving it like that. But if you wanted to write it like this, that is where your negative is. Next one. Is there a common factor? Yeah, what do I want to factor out? 2. Okay. On the inside, I see subtraction. Is it difference of squares? No, what about difference of cubes? Yes. So keep that 2 out front. And write out your difference of cubes. Okay, it's difference, so a minus b, so t minus 2, and then t squared plus 2t plus 4. A is t, b is 2. I have a trinomial. Do I have a common factor? No. So factors of 36, let's think. 6 and 6. Can I get 14? No, because I have to think in my head that I'm subtracting the numbers because you have one positive, one negative. No, not 6 and 6. Let's see, what about 9 and 4? No. What about 12 and 3? 18 and 2? 36 and 1? Did anybody find a way? No. Okay, any questions about that?